This is the Pokedex you wanted when you were a kid. A fully functional dex that looks just like the one in the show, with a high-resolution screen, scratch that, screens, that can not only show you the complete Pokedex entries for all your favorite Pokemon, but also identify them by taking photos in the real world. And this is the actual Pokedex you might have had when you were a kid. To be fair, this is the first Pokedex you could ever get in America way back in 1998. This Tiger Electronics toy may not seem all that impressive today, but when I was a kid, I wanted one so bad. I still want the closest thing to a real Pokedex possible, but my dopamine-exhausted millennial brain needs at least 10 times the stimulation to feel anything these days. So just buying this vintage toy wasn't enough to spark joy. So if I really want it, I'm gonna have to do it myself. And by myself, I mean with a friend. I need to collaborate with a real Pokemaniac. Someone not only deeply obsessed with Pokemon and committed to his Poke craft, but also someone who actually enjoys and is skilled at writing code. And there's only one guy with 2 thumbs and a lab coat who's right for the job. Who's that YouTuber? This video is brought to you by PCBWay. It's Big Rig Creates! If you don't already know Matt, aka Big Rig Creates, he's a talented creator who's made dozens of videos bringing the Pokemon world to life. And he's the code wizard who wrote all the software for this Pokedex. So you should watch his video after this one. Right now, I'm going to show you how I designed the physical dex.
There's just a small problem. We don't know how the Pokedex works. That might sound crazy, but I'm specifically referring to the classic Kanto Pokedex that Ash uses in the Indigo League series. You might think that across dozens of episodes, we see all of the features of the Pokedex, but it turns out animating hands is hard and expensive. So 99% of the time, the only thing the Pokedex does is ding, show a plain picture of a Pokemon, and tell Ash that he's stupid or something. Now, this isn't a bad thing because it means there aren't any tricky canonical features getting in the way of our design and we get to make them up for ourselves. If I get anything wrong, be sure to leave an incredibly detailed comment down below. But the real question is, how do we go from this, just an idea on a piece of paper, to this, a real physical device? Well, the way I see it, we need to define what physical features the Pokedex actually has.
The way I see it, we've got 4 lights, 5 screens, and 22 buttons. Not to mention the implied microphone, speaker, and camera somewhere. And battery, processor, the case itself. It's a complicated gadget. There's a reason why the toy only has a single functional side and an itty-bitty monochrome LCD.
But we live in the distant future of insert current year here, and making bespoke electronic devices has never been easier. So let's talk about all of the physical features of the Pokedex and how I brought them to life. The main screen is where all the action happens. We need it to not only display Pokemon and act as a viewfinder for the camera, but to be the primary user interface for the Pokedex. So I went ahead and chose this 2.8-inch LCD, which has a resolution of 640 by 480, aka VGA, which is that perfect 4:3 aspect ratio that all the kids crave these days. And I think that is fitting for a device that was designed in the 90s. Now, this is a DSI display, which means it's actually plugged in via a ribbon cable directly into the Raspberry Pi compute module that's tucked inside the Pi.
Now, there's no clear answer as to what this mysterious rounded rectangle below the main display is, but I have an obsession with small screens, so I made this a small screen too. In my Dex, it's actually a full-on ESP32 with an LCD that has a resolution of 320 by 172, which I point out because I find it funny that this mini display dev board has more pixels and processing power than a Game Boy Advance. This little lad shows the current Wi-Fi connection, battery level, and game setting, because each game has its own distinct Pokedex entries. You can swap between game versions to read your favorite entry. Now there's a few more would-be displays on the right side of the Dex, so I picked out some crispy white OLEDs. These have just enough pixels to showcase the text entries and type data of a Pokemon. If an entry is too long, you can flip between pages with the white buttons down below. Now, next to Dexter's blue eye, the OG Pokedex also has 3 red, yellow, and green pips. I can't recall them ever actually lighting up, but these reminded me of regular 5mm LEDs, so that's what I used. To put them to use, we decided they would be a great battery level indicator. That was a pretty simple feature to figure out, but Dexter's eye is a bit bigger, so it needs a little more work. It's also just a blue LED inside, but to make it the exact shape, I've glued it into a clear 3D printed resin lens to diffuse it and match the model. And whenever Dexter speaks, the eye modulates based on the audio levels.
Hours a day. If it senses danger, it will teleport itself to safety even as it sleeps.
Now the Pokedex has keypads with plenty of buttons on both halves of the case, and I've designed all of the buttons to use the same extra clicky tactile switch. To keep everything tidy, I designed 2 custom PCBs for each side, one for the main half with the D-pad, and a larger PCB for the side with the built-in Raspberry Pi Pico. I don't have a custom PCB factory in my garage, although I do have PCBWay, and so do you. PCBWay can manufacture custom PCBs as simple as 2 layers all the way up to 14, and more. With tons of options like custom solder masks and silk screens, you can upload your custom Gerbers and get a quote for your PCBs in seconds. The PCBs I received were exactly what I ordered and worked great. If you need custom PCBs, PCBA, advanced 3D printing, or CNC machining, check out PCBWay. Star transition. There's a lot of buttons, so I'm not going to run through them all, but you can pause now to learn their secrets. At the end of the day, the Pokedex is just another mobile computer. So we spec'd out a Raspberry Pi Compute Module 4 with Wi-Fi, 4 gigs of RAM, and 16 gigs of eMMC for storage. The Pi is connected to the main display and camera via a breakout board, but it can't control everything. Since the ESP32 power display is closer to the buttons, they're all wired directly to that board, and the ESP32 just shares which button is pressed and passes it along to the Pi. But what about controlling the side case? In order to keep wiring as simple as possible, there's just 4 wires for power and data running from the main case to the side. There's a hole in the top left of the case that lines up with the hinge, and a small cutout in the upper right of the case for the wires to feed through. This way the wires can rotate freely without getting pinched. The side case itself is controlled by a Raspberry Pi Pico. It can handle talking to all 3 displays while also reading all of the buttons. The Pokedex needs some way to play audio, because we need the iconic ding and voice of Dexter, and I want it to be loud, so I tucked a 3-watt speaker and amp inside the case. This little grill isn't going to cut it for audio, so I designed an open slot hidden beneath the hinge. But don't worry, that little grill below the screen isn't wasted. In my version, that's actually where the microphone goes. You might have noticed there's a lot going on inside this device. We need a lot of juice to power it up. For the battery, I'm using a protected single-cell LiPo. That gets boosted to 5 volts by the AmpRipper 4000, which gives us plenty of current headroom for all the components. I can switch the Dex on and off via the slide switch that's built into the board. It's a bit too small and delicate, so I made a chunky finger-friendly cover for it. I also added a 3D printed light pipe so that when I plug it in via the built-in USB-C port at the bottom, I can see that everything is charging nicely. Now, the Dex has a lot of fiddly bits and fine details that are tricky to make without a 3D printer. I made the model in Fusion and split it into pieces mostly based around color for easier painting and assembly. I designed the main components to be printed out of resin on my Form 4 3D printer. This is an SLA printer that cures liquid resin layer by layer with UV light. The parts get a quick wash in an isopropyl alcohol bath before moving over to the UV curing oven for a final bake. I never get tired of watching SLA resin parts cure, it's so deeply satisfying. Once I've baked all of the parts, I can give them a solid look over. I printed most of the parts out of standard black resin. All of these parts need to have their Art Deco scaffolding removed before I can see if they printed properly and I didn't forget any details. As with most of my designs, the models came out right the first time and there weren't any design flaws. The Raspberry Pi and power supply inside could get pretty toasty, so I designed the rear case to be machined out of some aluminum plate I had lying around. I wanted to keep things nice and compact, so that meant machining pockets for the Pi and camera. In order to turn this plate into a finished part, I have to create tool paths that tell the machine exactly how to move so that my desktop CNC knows how to move safely. One small mistake in the toolpath programming and the part could be ruined. Let's watch it in action. Thankfully, I managed to only break one end mill while machining. It's not like I left a tiny carbide shard that I didn't notice, causing me to break an M2 tap in the exact same hole later on. That would be maddening. Actually, everything turned out alright in the end. I was able to save the part, and once I sanded it down and coated it with some spray paint, all my crimes were hidden, which I feel like is par for the course. Now with this part complete, there's only one thing left to do, and that's turn the Pokedex on. And here it is, the final Pokedex in all its glory. I can't begin to describe how exciting it is to finally be able to hold this thing in my hands. I've wanted it for decades. Granted, it is a little bit bigger than the original toy, but I think that's pretty fair given that this is a real functional Pokedex, and it's something I can touch and use in the real world. Like, look, I can take a photo of a Bulbasaur.
Bulbasaur, PC Pokemon. It can go for days without eating a single morsel. It can walk on its back. It stores energy.
But we can also ask it about
moves. So let's go back to ask. Ask, when does Blastoise learn Hydro Pump?
Blastoise can learn Hydro Pump via level 52 in Pokemon Yellow.
It's perfect. It's perfect. All right, so the Pokedex isn't actually perfect, but I think it's pretty good. Honestly, I can't get over how satisfying it is to hold and interact with this thing. It is so much fun, and it really feels like my childhood come to life. And I hope it gave you that feeling too. And if so, be sure to subscribe to see more fictional technology like this come to life. And if you want to learn more about the Pokedex, you should watch Matt's video right here. Thanks again for watching. See you guys in the next one.